Imagine looking up at the night sky tonight and seeing not one, but two massive, glowing moons hanging in the darkness. At first, it sounds like a breathtaking fantasy, a beautiful cosmic upgrade to our night sky. But if this alternate reality actually came to pass, it would trigger a planetary chain reaction so violent that it would rewrite the history of our world and potentially bring about the end of human civilization. Our current moon is far more than just a beautiful nightlight. It is the invisible anchor of our planet. For billions of years, its gravitational pull has kept Earth's tilt stable, giving us our predictable seasons. It acts as a cosmic brake, slowing down our planetary rotation to give us a comfortable 24-hour day. And it gently pulls on our oceans, creating the steady tides that allowed early life to transition from sea to land. But what happens if we disrupt this perfect cosmic balance? What if a second moon, roughly the same size as our own, suddenly appeared and settled in an orbit halfway between Earth and our current moon? The moment this new moon arrives, its proximity means its gravitational pull on Earth would be 8 times stronger than what we experience today. Instantly, the Earth's crust would begin to stretch and buckle under the immense gravitational strain. Massive earthquakes would rip through major fault lines, and long-dormant volcanoes would violently wake up, spewing ash and sulfur into the atmosphere. But the most immediate and terrifying threat would come from the oceans. The dual gravitational pull would generate monstrous tides, creating tsunamis hundreds of feet high. These walls of water would wash over coastal cities, erasing entire populations and redrawing the map of the world. But here is the most incredible part of this scenario. This isn't just a wild science fiction theory. According to planetary scientists, Earth actually had a second moon once. Around 4.5 billion years ago, a Mars-sized planet named Theia slammed into the infant Earth. This cataclysmic impact blasted a massive ring of molten debris into orbit. For a long time, we believed this debris formed only our current moon. But recent computer models and geological evidence suggest a different story. The debris actually coalesced into 2 separate moons, our current moon, and a smaller sister moon that trailed quietly behind it in the same orbit. For tens of millions of years, early Earth was orbited by 2 companion moons. But this cosmic partnership was doomed to end. As the 2 moons slowly migrated outward from Earth, the gravitational balance became unstable. The smaller moon was pressure-cooked by gravity and drawn toward the larger one. But instead of a high-speed, explosive impact, they collided in what planetary scientists call the Big Splat. Because they were moving at a relatively slow velocity, the smaller moon didn't shatter the larger one. Instead, it pancaked across its surface, splatting like a pie in the face. This slow-motion cosmic collision is the exact reason why the far side of our moon is so mountainous and has a much thicker crust than the side we see from Earth. The lopsided moon we look at today is the literal fossil of our long-lost second companion. If we were to capture a new second moon today, we would quickly find ourselves fighting a losing battle against the laws of physics. Specifically, a famous mathematical dilemma known as the three-body problem. When 3 massive objects, the Earth and 2 moons, interact gravitationally, their orbits become chaotic and highly unpredictable. Over time, the gravitational tug-of-war would warp the orbits of both moons. They would eventually suffer one of 2 fates. Either they would experience another cataclysmic big splat directly above our heads, raining molten debris down onto the Earth, or one of the moons would be violently slung out of orbit, hurtling into the freezing vacuum of deep space. Even if the system managed to remain temporarily stable, life on a 2-mooned Earth would be vastly different. With 2 moons reflecting sunlight, the nights would be up to 4 times brighter. The concept of true darkness would vanish. This would completely disrupt the migration, hunting, and mating cycles of nocturnal animals, and throw human sleep biology into total chaos. Our oceans would remain wild, unpredictable, and highly dangerous for navigation, delaying global exploration and trade for centuries. Ultimately, looking at the hypothetical chaos of a 2-mooned Earth reveals a profound truth about our own world. Our single, lonely moon is a cosmic masterpiece of precision. It is not too close to cause global destruction, yet not too far to let our planet wobble out of control. It sits in the perfect sweet spot, silently keeping our oceans moving, our days steady, and our seasons constant. Our solitary moon is a quiet reminder that sometimes, the perfect recipe for life doesn't need an upgrade. It just needs the perfect balance.